Okay, so now let's move to question number 5. We call a positive integer n 2 prime if it has exactly three different divisors, namely 1, 2, and n itself. How many different 2 prime integers are there? So they're saying that an integer is called 2 prime if 1 divides it, 2 divides it, and n, the number itself, only divides it. So let's look at different numbers. 1 is the only divisor for 1. 2, if we take 2 as our candidate for 2 prime, it would be its divisor would be 1 and its divisor would be 2. There's no third divisor. Exactly three different divisors. So this cannot be the case. What I can see here is there's only one number that comes to my mind, that is 4. Now 4 divides 4, 2 divides 4, and 1 divides 4. So no number greater than 4 can divide 4, right? And no 3 cannot divide 4. So hence the 4 is the only candidate that I can see. Now what I am seeing here is 4 is the candidate because 4 is created when 2 is multiplied by itself. Let's say we multiply 2 by 3 to make another divisor. 2 multiplied by 3 is 6, right? Now 6 has 4 divisors, 1, 2, 3, and 6 itself. Let's take 2 times 4. Okay, so this will be 8. So 8 has divisors 1, 2, 4, and then 8 itself. So again, this has 4 different divisors. Any other number, let's say 2 multiplied by 5, 2 multiplied by 6, 2 multiplied by 7, any of those numbers would be divisible by 2 and divisible by 5 and then divisible by themselves, right? 2, n, and 1. There should be no fourth, but this is the fourth one that would be coming. This is the fourth one that can be seen here. This is the fourth one that can be seen here. So that means that there cannot be any other number other than 2 being multiplying by itself. So 2 multiplied by 2, we can have that as our case since it is the same divisor. So the answer to this would be part B, which is 1 integer only. How many different 2 prime integers are there? There's only one 2 prime integer, that is 4 itself. Now this question is a little tricky, but it's not too difficult. Now why am I saying it's a little tricky but not too difficult? Let's look at it. How many pairs of positive integers x and y satisfy the equation x plus 2y equals 2 to the power of 10? Now what I can see here is, firstly, I need positive integers. Secondly, the integers that I need are, the y should be a multiple of 2, okay, while x is after taking x out, the remaining part should be a multiple of 2. So that means from this, which is an even number, I need to take something out such that an even number is left. The reason for that is 2y would be equal to 2 to the power of 10 minus x. Now 2 to the power of 10 minus x needs to be even because it is equal to something that is a multiple of 2. So whenever we multiply an integer by 2, the answer comes out as a even number. So 2 multiplied by any integer will always give us even number, and we know that 2 to the power of 10 is also even. So when we are subtracting something from 2 to the power of 10, that must also be even to produce the result as an even number. So 2 to the power of 10 minus even will produce even. Otherwise, it would produce an odd number. 2 to the power of 10 minus odd will give us an odd number. As a very rough example, we can see that 4 minus 1, which is odd, is equals to odd, which is 3. Okay. So this is a very rough example, but just for the understanding of it. Now That means x must be an even number. Let's take the smallest even number, smallest positive even integer that we have, and let's just say x is equals to 2. So let x equals 2. If x is equals to 2, then 2y must be equal to 2 to the power of 10 minus 2. Okay, so this will result, let's take 2 common from here. So 2y is equals to 2 times 2 to the power of 9 minus 1. All right, now from here what I can see here is x plus 2y is equals to, let's just say 2 times 2 to the power of 9 minus 1 plus 2. Okay, I've just added x on both sides, you can say. So plus x and plus x, since x is equals to 2, I've written 2 here. Okay, so since I have added x on both sides, what I can see now is x plus 2y is such that this is the case. Now from here, the next number that comes to my mind that I can put here is, let x equals 4, because it has to be an even number now. It would only be incrementing as an even number. So let x equal 4. So our y, or rather 2y, will become 2 to the power of 10 minus 4. So 2y will become 2 times 2 to the power of 9 minus 2. 2 to the power of 9 minus 2. So from what I can see is, this will be our first both positive integers, our second both positive integers. Okay, and when I get to the second both positive integers, I get 2 to the power of 9 minus 2. From what I can see is, if I keep on incrementing like this, okay, so the first y was 2 to the power of 9 minus 1, the second y1, y2, 2 to the power of 9 minus 2, y3, 2 to the power of 9 minus 3. Okay, and so on and on I can go until my y will be 2 to the power of 9 minus 1. The reason I'm saying 2 to the power of 9 minus 1 is 2 to the power of 9 minus 2 to the power of 9 minus 1 will result in y 2 to the power of 9 minus 1 being equal to 1. And I cannot go further down, because that would make it 0 and that would eliminate us. So now what I can see is the total number of answers that I can see, or the total number of pairs that I can see here, are first pair, second pair, third pair, 2 to the power of 9 minus 1 pair. There is no next pair left. So there are 2 to the power of 9 minus 1 pairs. So the answer will be A, 2 to the power of 9 minus 1. Now let's look at this question. Two equilateral triangles are put together to form a hexagon with their opposite sides parallel. We know length of 4 sides of this hexagon as shown in a diagram. What is the perimeter of the hexagon? So what they're saying is that this side and this side is parallel, this side and this side is parallel, this side and this side is parallel. That is what they're saying. So looking at it, what I can see is, if the opposite sides are parallel, if the opposite sides are parallel and each of these triangles is an equilateral triangle as said here, that means this angle will be 60, and since this side and this side is parallel, this angle will be 60 as well. Okay, and same would be the case with every single angle. This angle will be 60 because this angle is 60. Similarly, this will be 60 because this angle is 60, and since these two sides are parallel, right? So similarly, all the different triangles that are formed are equilateral triangles. If all the different triangles are equilateral triangles, then that means if this is 12, then this must be 12 as well, and this is 12, this is 11, then this is 11, and this is 11. The reason I'm saying all of these are equilateral is this is 60, this is 60, and this is 60. All three angles are 60. This triangle is an equilateral. Then 15, so 15, 15, 6, 6, and 6. Now, what we need to find is what is the perimeter of the hexagon. Perimeter is just the outer side altogether added together. So for that, we will use again the same method that we used in the second question, okay, which was if we have a shape such as this staircase, then this whole side will be equal to the sum of the smaller sides here. So we'll use the same pattern here. Now, just a little bit different, although, but yeah, let's see it. Let's look at it in action. So, since both of these triangles are equilateral, okay, two equilateral triangles are put together to form a hexagon. So yeah, let's look at it. So this triangle here has the total length as 12, 11, and 15. Okay, while this triangle here has the total length as 11, 15, and 6. So let's take this triangle as A and this triangle as B. So triangle A side equals, triangle A's side is equal 15 plus 11 plus 12. Let me just color code it. 15, 11, 12. 15 plus 11 plus 12. Let's color code the other one as well. Triangle B has 11, 15, and 6. So triangle B has side 11 plus 15 plus 6. So the first one comes out as 30 and then 38. Yeah, the second one comes out as 16 plus 6 is 32. 26 plus 6 is 32. So triangle B has the sides 32. Triangle A has the sides 38. Okay, so now let's look at the sides that are not given to us and try to find out those sides. What we know is that if this is 6, okay, all right, this whole length complete from here to here is the length of triangle A. Okay, so 15 and 6 subtracted from 38. 38 was the total length, minus 15 minus 6 would give us, so 32 minus 15 is 17. Okay, so this is 17. Similarly, this is 17, this will be 17, and since this is 17 and this is 6, we can now find this length as well. The total distance from start to end here would be 32. 32 minus 17 minus 6. So 32 minus 17 is 15, minus 6 is 9, making this length 9 and this length 9 and this length 9. Now to find the perimeter of this hexagon, we just need to add all the outer dimensions, right? So let's write down all the outer dimensions. So all the outer dimensions, let's start from here. Okay, I'm marking it out so that I do not get confused here. 6 plus 6 plus 15 plus 15 plus 11 plus 11 plus 12 plus 12 plus 9 plus 9 plus 17 plus 17. So this comes down as 30, and then 20, 20, 18, and then again 18, and then 17 and 17 are, let's say, 34. Okay, so now let's add them all together. 18 plus 18 is 36. 18 plus 18 is 36 plus 30 plus 20 and 20 are 40 plus 34. So I'm looking at it. What is the perimeter of the hexagon shown? So I think, oh, all right, sorry. So my mistake here. So we have found all the sides, right? Now hexagon is this shape inside, not the star outside. I was thinking it was the star outside. So hexagon is the shape inside. Now I got to know about that by looking at this and looking at the answers given to us. Nothing match, right? Now the logic here of finding the sides would remain the same. Okay, so let's add all the sides inside now instead of outside. Okay, so let's erase all of this since all of this was wrong. Now, so it would be 17 plus 6 plus 15 plus 11 plus 12 plus 9 so 17 plus 6 is 23 plus 15, 23 plus 15 is 38 plus 11, 38 plus 11 is 49 plus 12, 50, 9, 61, 61 plus 9, 70. So 70 is our answer here. Okay, now it is very key to note down what they are talking about, which perimeter they are talking about. They are talking about the perimeter of the hexagon. For some reason I was thinking that this star shape outside is hexagon, when in fact the hexagon is the inside shape. And since they use the word perimeter, I thought they were talking about the outside length. So I was thinking about that. So it's very important to see what they're talking about. And as we can see here again, this is also a hint. We know length of 4 sides of this hexagon. 4 sides of this hexagon, the 4 sides that are given to us are the inside sides. So we just needed to find this side and this side. Okay, the logic was the same. The whole working remained the same until the very end. So there's no problem here. Now, this question right here, this is a question of an infinite series. The reason I'm saying it is an infinite series is this repeats infinite number of times. So let's read the question again. A square with an area of 84 is divided into 4 squares. The upper left square is colored black. The lower right square is again divided into 4 squares, and so on and on. This is repeated infinite many times. What is the total area of the colored black? So we have this area, then this area, this area, this area, this area. Now since it is repeating infinitely many times, and I can see that every single time it is a multiple of the section that we have, or rather this section and this section is the same, and the section that is colored inside is again a multiple of the previous one. So I'm looking at a geometric series here where the first value A will be this shaded region. So the first square will be our the first value A, which is 84 over 4, because the total area was 84. Total area was 84 divided into 4 parts. We get 84 over 4, which is 21. So our A here is 21, or we can even leave it as 84 over 4. So let's leave it as 84 over 4, and you'll see why I'm leaving it as 84 over 4. The next thing that we need to see here is the ratio, the common ratio R. In this case, the common ratio R is, if we look at it, the common ratio R is 1/4 of the previous one. This yellow box represents the black box here, and then this purple one represents the area of this yellow box that we would be using. So this purple is what? Purple box is equal to 1/4 of the larger yellow box. Okay, so that means that the common ratio here that we have is 1/4. Now in an infinite series, when we are multiplying, since it's an infinite geometric series, the formula that we have for the sum up till infinity is equal to a over 1 minus r. So a over 1 minus r, our a is 84 divided by 1 minus 1 over 4. The a is 84 over 4. So this will become then 84 over 4 divided by 3 over 4, because 1 minus 4 is 1 minus 1 over 4 is 4 over 4 minus 1 over 4, which is 3 over 4. Okay, so this can further be written as 84 over 4 multiplied by 4 over 3. 4 and 4 cancels, 84 over 3. Now 84 over 3, so 3 ones are 3 twos are 6. Okay, 3 twos are 6, and then remainder is 2. 3 ones are, and then 3 eights are 24. So the answer here is 28. Okay, so 84, 3 twos are 6 minus 2 4, 3 eights are 24 minus, and this gives us our answer 28. So the answer here is B, 28. Now let's look at it in the next part.